Alright, you guys, just got home from work. Not exactly straight from work. I went to the post office first and I got an Amazon package with some mostly toiletries, but more importantly also my new driver for my stepper motor. And then I got some epoxy because I figured out that my solution is going to be for the whole like sliding of my attachment on the axle of the stepper motor. My solution is going to be to just glue the collars around where there's like the hole in the center of my like plastic ruler, and then those collars can then be tightened on to the axle, so which is a D shaft. So that it's, you know, I went over that in a previous clip. So here it is. I'm gonna crack this open and let's see what we've got here. I think there's two of them. Hopefully, yes, two of them right here. I don't know if it's gonna focus, whatever. It's like, it's not a real YouTube unboxing if the person doesn't hold it up and hold their hand behind it and be like, oh, is it gonna focus? Anywho, so I bet I could get just one of these. There's like plastic over the top so I can keep the other one in the little package here as a nice backup. But actually, if I cut this first, cut this in half. Okay, so now we got the backup separated here. I can open up. I don't have any nails because I regularly cut my nails for jiu-jitsu, obviously, but just to be a clean person. Got the heat sink here. Have this little card with the pin out. So, got that. It's not focused, whatever. Pin out, and then it's got their logo on the back. And then we have the driver. Ooh, so we've got, what, 8 pins, and then I can just pop this out of the driver breakout board, the old one, the DRV8825, which also has 8 pins. So yeah, here's the old one with the heat sink. Again, that's a DRV8825. Okay, there it is, focused. And then here is the TMC2209. Alright, good deal. And if I'm not mistaken, these have the same pinout, question mark. Okay, well, first things first, I'm assuming it's the same, but I might have to change some stuff. I'm going to apply the heat sink here. So scrape this little adhesive backing off. And then I'm just going to plant this right on here. Whoops, that's a little bit off. Before I press, I'm just gonna kind of, I don't know, that's good enough. The heat sink doesn't cover the whole entire thing here, but I'm gonna try to center it on where the main chip, the chip is underneath, then put it on top, versus on the DRV8825, the main integrated circuit is on the top of the board. So it's underneath the heat sink there, and then this is the top of the DRV8825. Okay, fail on the focus, and then here is where the chip is on the TMC2209. So the heat sink is not directly on top. But, okay, I will need to double check the pin out. They have the same number of pins, so it can be used with the same stepper motor driver breakout board. So I'm assuming it's the same. I don't know, I'm gonna have to look that up, but I guess that'll be in the next clip. Alright, so back with another update in this hodgepodge throwaway vlog, you know, doing the behind the scenes, building up to my big video that I've been planning for months now. So, okay, I'm building my experimental apparatus, right? I need to turn this around. We've got here stepper motor. I have my plexiglass protractor ruler attachment. I made a new coil. This one, I'm gonna say still is approximately 100 coils, coil winds that is, but I'm pretty sure that it's exactly 100 because I'm more familiar with how I set my jig up with the Hall sensor and everything. Okay, anyways, so it's a little bigger. I put it on a PVC coupler. It was before on like the pipe, and I had used a jigsaw to cut segments of the pipe, but I was just like, okay, I'm just gonna buy a coupler that's a little bit larger. And now the magnet and the protractor are fairly nicely in the middle, and I did kind of like a dry rotation, and this should be good. It kind of maxes out at the extremes of the angles where it gets a little bit thick here, where I started to cut the plexiglass linearly before going into the circular portion. So like right about here, it's not going to, you know, fit in the coil necessarily, but that's okay because really what I want is for this to swing out, and then when it gets to a point where there's essentially no induced current, it's going to swing back. So there will ideally be a smooth periodic sinusoidal oscillation. Anyways, okay, so I lowered the stepper motor and such. I put this on a different clamp. So when I remade this coil, I put some electrical tape around it so that this clamp can securely fasten around the coupler that I wrapped the winds around. So this is more solid. And then I spliced on insulated ends of wire, you know, and I soldered the splicing together, and then I put heat shrink tubing around. So this coil is way more solid now. And it's a little bigger, which is arguably the most important part. But then, okay, I put the new driver on this board here. I used to have a DRV8825, and then I had a breakout board specifically designed for that, okay, the DRV8825, but now we're using a TMC2209. So that probably doesn't mean anything to any of you guys, but ideally, the problem with the DRV8825 was that it would be way too jerky. And so controlling it was kind of a hassle, and it would torque this around, and it was also loud, and so I looked it up, and supposedly this is a better driver. But it's a bit finicky, and I haven't gotten it to actually control the stepper motor yet. I've been trying to get the VREF, the reference voltage on here, because there's like a potentiometer on here. Probably not going to focus and be able to see it. It's like right there. Anyways, so I have it like worked up to my multimeter right now, and I've been trying like grounding or just leaving floating certain pins, stuff like that. Like before with the DRV8825, I could power it with just the 12 volt power supply and then set the VREF. But this one, I also have to have the Raspberry Pi powering it with 3.3 volts on pin 1 on the GPIO header. I could have done, I feel like I could get away with 5 volts as well, but I feel like right now I have a common grounding issue because this one right here, I'll ground it, and then there'll be like a torque on, like a small torque, small little tiny movement on the motor. No script running, okay? And whether or not I have this enable pin grounded or not changes what the VREF range looks like on the potentiometer. So it's been pretty weird. I think there's like a mode that's enabled by default called UART mode. You know, it's like I'm not an EE, an electrical engineer, so it's like, you know, I'm kind of learning about this stuff by doing this project. But when the UART mode is selected by default, or if the chip is not in like a valid configuration as far as like the pins go, then it'll default to that, and then the physical potentiometer as far as setting the VREF is just disregarded. It just goes by software, and then it's limited to like 0 volts to 600 millivolts. And then in order to drive this stepper motor, I need at least a volt, 1.25, 1.3. And so it's kind of like with the common grounding issue, I'm worried that I might not be giving enough power to the motor right now, but I also don't want to just like crank that Soldier Boy and then burn out my motor. I mean, I have a few extra ones, but it's like, okay, I attempt to go super high on the voltage, blow one out. It's like, what's my next step after that? Because lower voltage, like a lower VREF voltage didn't do anything. You know what I mean? So it's like, I feel like, you know, it's probably some kind of combination of disconnection versus grounding that I haven't tried out yet, because there are these other pins that weren't in use on the DRV8825. And so I'm like, okay, I'm like reading online and, you know, doing all that stuff and like, okay, I'm going to ground them, but then it's still not working with my script anyways. And yeah, so I guess still to do, since I have heat shrink tubing, I'm going to probably redo some of these connections for the coils on the stepper motor, because this is just electrical tape. You probably can't see that, but just to kind of clean it up a little bit more. And then I have to add, I guess I intend to make my whole experimental apparatus complete, put a Hall sensor inside the PVC coupler, the 100 winds of coil here, so that I get the magnetic field reading as the magnet swings in and out. Once I get this motor moving, right? Oh, another big update, I guess, or it's not that big, is I epoxy sealed 2 collars onto the ruler segment here. Because if you watched my last one, probably not. There's probably only a few of you who actually watched it, and you probably watched it to fall asleep, but that's all good. The hole that I drilled right in the center here where the axle is going through is the same size as the shaft of the stepper motor, but the stepper motor axle is a D shaft. So it was a little bit loose. It wasn't completely flush. So I just glued or epoxy fastened, attached. I don't know what the epoxied, I don't know. Threw some epoxy onto some collars, and then now this is like really snugly fit on here. So I'm not gonna jank it around too much, but it slides on a lot easier, and then I just tighten the collars, and then it's on here. So like I was feeling when I would have my driver troubleshooting going on earlier, I could like turn on a script that would be like powering the motor supposedly, and then there'd be like a holding torque. So like right now it's like pretty loose, right? But if I have that script running and I would have done the same like little push, it would be just holding steady. So, but you know, you watch the last one, I've still got my MCP ADC, analog to digital converter, MCP3424. That's just like the model number. But when this is all done, I'll have this. It's not connected to anything. This will be connected to the coil and the Hall sensor. Then I've got the magnetic encoder. so I can get the angle readout of where the magnet is, and between magnetic field readout from the sensor, induced current, angle, and this thing is oscillating, the periodicity should be, you know, the frequencies should match more or less, or the action should. Like if I swing one direction, then the induced current, angle, magnetic field, like I could then stop it. Those curves should more or less coincide, ideally. But then, okay, right, like I've been using the Hall sensor in the meantime. You can't really see it because it's under this, this compass, but it's taped down on top of Maxwell's Treatise on Electromagnetism Volume 1. I thought that was a fitting book to tape my Hall sensor down onto for when I wound my latest iteration of the coil here. So like a sensor like that is going to go on the inside of this. But on my to-do list is I also would like to use the Hall sensor to just measure the magnetic field strength of the magnet type that I have inside of here right now. And to get that for like the north, south, and side of the magnet, you know, like the cylindrical, tangential portion, whatever you want to call it. Just, you know, to really be thorough on the science side. And I mean, yeah, that's kind of what's been going on with that. I am about like probably 100 pages left in 1929. I'm a little bit tired from going to jiu-jitsu on Friday and then lifting legs today. Today's Sunday, by the way. And I still have to get groceries. I don't know if I'll share the outcome of the haul with you guys. I'll probably will, because it's going to be the same as the last two. And yeah, so my goals, at least today, I'll probably be able to like throw the heat shrink on the coils coming off of the stepper motor to clean that up, and then I'll call it a weekend for that, because I can't figure out what's going on with this driver right now. Read 1929, and I didn't do any work this weekend, which is good. I have had the intention to, haven't gotten around to it. It's kind of like, you know, it could only benefit me, I feel like, at this point, to get a little bit ahead on the work, but I'll probably just read the C# programming book a little bit. I have some stuff that I have to take care of that I have to make sure that I'm like up on in order to discuss the code with other people. But I think, so it's 4:16 right now. I might as well go get groceries. And it's warmed up relative to the last few weeks, so shouldn't be too bad. I don't know. Maybe, and I have to edit this video together too, so that's... Anyways, I'll stop rambling now. See you guys in the next one.